Chapter 5, Section 7, Scatter Plots and Trend Lines. For these three, you just need to draw a sketch. A scatter plot is when you're given a set of coordinates, a set of points, and you plot them on a graph, and they don't form a line. But there are three types of correlations that they do form. The first is a positive correlation. Just like a positive slope, you have the scatter plot. Our trend line, which would be the blue line, our trend line shows that there's a positive correlation. Negative correlation would be just like a negative slope, and our blue line, again, our trend line, would be a negative correlation. No correlation would be when they have nothing to do with one another. So the points are just scattered literally all over the graph. Now, causation is a word that you need to understand. So think cause and effect. One variable directly affects the other variable. An example would be the number of hours studying and the grade on a test. Those are two variables, number of hours and your grade, which are causal because they affect one another. If you study more, you'll get a better grade. Can you think of two variables which are not causal? Write down your example in pencil, bring it to class tomorrow, and we'll go over any questions that you have, see which are good examples, which could be stronger examples, something that you could put down on a test. So causal relationships will always have a correlation, but two data sets that have a correlation may not have a causal relationship. So in other words, causal relationships always have a correlation, but just because they have a correlation doesn't mean they're causal. An example would be the amount of cookies made and the amount of sugar used. That's a causal relationship because if you make more cookies, you'll need to use more sugar. They affect one another. Another example would be the number of mailboxes in a neighborhood and the amount of firefighters in the same neighborhood. They will likely have a positive correlation because as the population increases, the number of mailboxes would increase and the number of firefighters would increase. But installing more mailboxes does not mean that you're going to need more firefighters. So they have a correlation because if the population increases, you'll need more mailboxes and you'll need more firefighters. So as more mailboxes increases, more firefighters will also increase. However, if I get a mailbox, that doesn't mean someone else needs to become a firefighter. So they're not causal, but they do have a positive correlation. So this is what we were talking about in class. In your calculator, how to enter in data. So we're going to do this for the example that we started in class. So I need my calculator, and you should take out your calculator as well. You are not supposed to touch anything else on the calculator. So when you press stat, and press enter on edit, you should still have these numbers in your calculator. So for the L1 column, we have 4, 9, 10, 14, 4, 7, 12, 22, 1, 3, 8, 11, 5, 6, 10, 11, 16, 13, 13, and 10. And you can see that my last numbers here line up. You should never have a number in L1 and a blank in L2. Every input has to have exactly one output. So this is our X, this is our Y. So you need to determine sometimes which is the independent and dependent variable, but in this case I'm telling you this is our L1 and this is our L2. So we need to then figure out how to plot this, how to actually graph it on the calculator. So the calculator can make a scatter plot. First, what you need to do is press second and then go to y equals where you see stat plot. And number 1, we want to make sure that our plot is turned on, so press enter on. We want to make sure that it's on a scatter plot, so press enter if it's not there. And we want to make sure that our x list is L1 and our y list is L2. If it's not, you're going to press second stat and enter in L1, and then do the same thing here, second stat and enter in L2. Okay? Now that that's done, we're going to actually graph and figure this out. Figure out what the line of best fit, what the trend line, the regression line, all of these words mean the same thing, what it is for this scatter plot. So we're going to press Stat. You're going to go over to Calc. You can see the steps here as well. Go over to Calc, and you're going to go down to Linear Regression, AX plus B. You can also use this one, but we're going to use it in this form because we want it to be slope times X plus Y-intercept. So down to number 4. Our X list is L1, our Y list is L2. You don't have to worry about the frequency list right now. Store reg EQ. That means store your regression equation. We want to put that into Y1. So you're going to press bars, Y bars, function, Y1. If you need to see that again, pause the video, go back and watch the steps again. Then you're going to go down to calculate. You should get this screen. You can see now that the A value, the slope, is 25.3264. It's going on and on. The B value, the Y-intercept, is 353 point and then numbers. For linear regressions, we're going to ignore R squared, but we are going to look at R. So if we wanted to graph it, now when we go to Y equals, since we put it in to store reg EQ in Y1, now when we go to our graph, so let's say we use zoom stat because we're graphing something statistics, so zoom 9. Now we can see our scatter plot and what our trend line should look like as well. If we wanted to graph it, most questions will say round to the nearest 3 decimals, so everything will be rounded to the nearest 3 decimals. We'll talk about how to change that in the calculator as well, but for now, just knowing the process is what I want to come out of this video. So now we have what the scatter plot looks like, what the trend line is. We have the equation of the trend line stored here, and I will show you how to show the calculator to round for you as well. But we want to figure out a few more things. So now we have our line of best fit, we have our regression equation. But we want to know what that correlation coefficient meant. So when we got that R equals number, well, that R equals number is called the correlation coefficient. It's a number from -1 to +1 that tells you how closely the equation models the data. So in other words, it tells you how good the line of best fit is. The closer it is to positive or -1, the more closely the data cluster around the line is a best fit. So if R is near 1, the data lies close to the line of best fit, which I'll show you on the graph in a second. So basically you want R to be close to -1 or +1. If it is, then it's a strong correlation. If it's closer to 0, then there's most likely no correlation. So when we look at our graph again, you can see how close all of these points are to the line of best fit. That's because this has a strong correlation. And if you go back to stat calc number 4, we already stored it in Y1, so we don't have to do it again. But just to see R equals again, you should always copy this number down as soon as you get to the screen. The correlation coefficient to the nearest 3 decimal places, so to the nearest 1,000, is 0.934. That is a very strong correlation because it's close to +1. If it's close to -1, it would also be a strong correlation. A lot of times they're going to ask you what the correlation coefficient is, and if it determines that the line of best fit is a good fit for the information, for the points that you plotted on your calculator. Now the other types of questions that you may get are about interpolation and extrapolation. Interpolation means you're estimating a Y value that's within the domain of the given sets. So a Y value that's in between the points that are given. Whereas extrapolation means estimating a Y value that's outside of the domain of the given data sets. So we can see in this example, and if you want to follow along on page 338, it's problem 2. It's asking us if we can interpolate the weight of a 7-month-old panda But in this case, we can interpolate the weight of a 7-month-old panda, because 7 months would be probably about halfway between 24 and 36. So you can see on the graph, since we're going up by 6s, that at 7 months it would be about 30 pounds. But you can't extrapolate the weight of a 3-year-old panda. Why can't you extrapolate here? Well, think about when you're a baby. You're growing rapidly. You're growing faster. Your weight is increasing rapidly over time. But by the time you hit, let's say, 3 years old, 5 years old, for us it's more like by the time we're in high school, we kind of stop growing. It's the same with a panda. A 3-year-old panda, a panda's gonna hit its weight around 1 or 2 years old. 3 years old, they're not going to be growing as much as they were when they were babies. They're going to hit their maximum weight or their average weight at an earlier age than 3 years old. So we can't extrapolate here because it's not going to follow the same trend line. The first year of life, you're growing faster than the years beyond that for a panda. Now I want you to go back and watch this video over again. Do the steps in the calculator, follow along on the worksheet that you were handed out in class today with the screenshots. Make sure you understand where everything's coming from, but more importantly, you're going to have to memorize the buttons that you're supposed to be pressing. Keep in mind that most of the buttons we're pressing say something about stat on them because we are working with statistics. But go through the video, go through the process. You don't have to enter in different data, but if you want to try different examples, you can try different examples and see what you get, see what works out, what buttons you're pressing. If you get any errors, write them down or take a picture of them and bring them into class so that if that same error happens on a test, you won't be confused, you won't be lost, you'll know what to do to fix it.